In this video, we'll be going over the recursive approach of binary tree post-order traversal. So given the root of a binary tree, return the post-order traversal of its node values. So in our first example, we're given this tree, which have the nodes 1, 2, and 3, and they want to return the post-order traversal. The direction of a post-order traversal is left subtree, right subtree, and then the root. So before we process this node, we want to process the left subtree, which we don't have, so we process the right subtree first. And then our right subtree, we want to process the left subtree first. So we get 3 first, and then we have 2, and then we have 1. Let's go over the dot process. So the direction of a post-order traversal is left, and then right, and then roots. Now we can go over the pseudocode. So we're going to implement our recursive approach. And then what parameters do we need? We'll need the roots, the current root node of the subtree. And then what's the base case? But before this, we need to create a list. So we're going to create a list values to keep track of all node values. And then we're going to implement our recursive approach. And then we're going to pass in our values, the list of all nodes. The list of all node values. We can call this node instead, or the current root node of the subtree. What's the base case? If node is equal to null, this means there are no values here, so we could just return from the recursive call. Then in each of the recursive call, we want to process the left and right subtree first. So we're going to recursively traverse to the left subtree, and then we're going to recursively traverse to the right subtree. And then we're going to add the current node value to the list or the current roots of the subtree. Because we have processed the left and right subtree already, we can add the current node value. So we can add node that value to values. Then we can return the values list. Now let's go over the time and space complexity. So the time complexity is O of n, where n is the number of nodes in the input tree. This is because we visit each node once. And then our space complexity is O of n plus O of h. But we still get O of n, where n is the number of nodes in the input tree, and h is the height of the input tree. O of n is our values list, and then O of h is the recursive call stack memory. Now let's go over the code. So we're first going to create our list values to keep track of all node values. Then we're going to implement our post-order traversal or recursive post-order traversal, and then we can return our values list. We're going to create our helper method, keeping track of our current node and also the list of all node values. So if the current node is null, this means there's no value here, so we can just return from the recursive call. In post-order traversal, we want to process the left and right subtree first. So let's process the left subtree, and then process the right subtree, and then add the current node value to the list. Let me know if any questions in the comment section below.